Hey everyone, so what you're about to see is a compilation of all of the TikTok videos I made about the new JWST images. I made about one per image plus a couple extra things, and instead of just filming the same thing here, I thought I would just put them all in one big chunk so you can see everything that I think and know about this first batch of full color science images. Hope you enjoy. The first science full color image from JWST is here. I'm a little emotional, but let's talk about it. What we're looking at here is a region of the sky that is as big as a grain of sand. Think of taking a grain of sand, holding it at arm's length. That's what this picture is. Almost every little speck of light in this picture is a galaxy. Again, the ones with diffraction spikes, those are stars in our own Milky Way. Everything else is a galaxy. All of this in a region the size of a grain of sand. The light from some of these galaxies has been traveling for 13 billion years. This is one of the deepest images of our universe we've ever seen. We are seeing galaxies as they were only 800 million years after the Big Bang. There's a galaxy cluster in the center that has some really strong gravitational lensing effects, and we could talk about that more later. But just take a second and feel small, be amazed at what this telescope can do. It took this image in less than a day of exposure. The Hubble Deep Field image took 11 days. Grain of sand, all of this, a grain of sand. Out 13 billion years. Tomorrow we get more images. And I'll be fine. I'm definitely emotionally prepared. We'll get images of nebulas, other galaxy groups, but this was the one I was excited for, the deep field. Do you want to see the image that caused an astrophysicist to do this?
That's heated by the core, the leftover very hot core of the star. And what about these, like...
That was me, seeing the JWST image of the Southern Ring Nebula for the very first time. This is the image. This is the Southern Ring Nebula, essentially a dying star. The core of the star is in the center, and it is surrounded by the gas and dust that were the outer layers it pushed away from itself. It is a stunningly beautiful image with an insane amount of detail. We also have an image in longer wavelengths, and in longer wavelengths you can actually see that there are two stars in the middle, not just one. And as these two stars orbit around each other, they push out this gas in asymmetric ways, which cause all of these beautiful internal patterns and structures. If that weren't enough, there's also other galaxies in this image. The Southern Ring Nebula is about 2,500 light years away. It's within our own Milky Way galaxy, but through it, you can see other galaxies. There's one right there, side-on view of a spiral galaxy. Right here, face-on view. There's another one right here. We're seeing our universe in a way we've never seen it before. And our universe is so beautiful. I'm gonna start crying again. Let's talk about the Karina Nebula. This is the image from Hubble Space Telescope. That was a beautiful image of the Karina Nebula. Until this morning, when we got this. This is a section of JWST's image of the Karina Nebula. Here's the full thing. So what is this image? Why is this an exciting image to have of space? The Karina Nebula is a region where stars are being born. It's a stellar nursery. This is all gas and dust, and that gas collapses and forms stars. Those newly formed stars produce radiation that lights up the gas and makes it glow all these pretty colors. JWST is an amazing tool to look at star-forming regions because there's so much dust. You see all of this here? That is dust, and visible light can't get through dust, so it just looks dark. But because JWST looks at longer wavelength infrared light, it can see through it. And we can see all of these structures and hundreds of stars that we have never seen before in this nebula. And that's not all. They also took an image of this using the mid-infrared detector, so detecting longer wavelengths in the picture I just showed you. And in the mid-infrared detector, you can see something really amazing. Dust glows in the mid-infrared, and one of the places where you have a lot of dust is around newly formed stars. We call these regions protoplanetary disks because it's the stuff that forms planets. So all of the little red and pink dots in here, what you are seeing is regions that are about to become solar systems. We are seeing the birth of stars, the birth of planets. Oh, and up here, a bunch of these little specks are actually other galaxies, too. This is an astounding image that immediately became my phone background because look at it! JWST is amazing. We are seeing the universe as we have never seen it before. This image from JWST has colliding galaxies, black holes spewing out materials, deep field images of the universe, shock waves through gas. Let me just show you. This is Stephan's Quintet. There are 5 galaxies in this image. The 4 along the right-hand side are about 300 million light years away from us. This one is about 40 million light years away from us, so it's much closer even though it's in the same region of the sky. This is a beautiful image that shows a ton of really, really fascinating things. For one, do you see this red arc here? This is a shock wave. This galaxy is flying through the cluster, shocking the gas in front of it, and you get this crazy disturbance with all sorts of star formation and bright, hot, glowing gas that's just beautiful. And it kind of looks like fire, which I think is really cool. This is an image JWST took with the mid-infrared camera, so looking at the same galaxies in longer wavelengths, and look at how different they are. This is a great example of how just changing the wavelength of light that you use to observe the universe drastically changes what you see. One other amazing thing they did with this image that I had no idea they were going to do was an analysis of an active galactic nuclei. AGN are supermassive black holes in the center of galaxies that are actively eating up a bunch of material, and in the process releasing tons of radiation and energy out from the galaxy. And this galaxy right here has an AGN, and they analyzed it. They were able to see through all of the surrounding stuff to the very center of this galaxy and precisely map out what elements are there. And not only what elements are there, but how fast are the elements moving. This is what the map of velocities is for argon, for neon, and for molecular hydrogen. This is just some really, really impressive data with really high resolution. This is the largest image that they released with all the new JWST images. The radius here is about 1/5 of the diameter of the moon. And there's one extra little bonus. If you zoom in, and not on the galaxies, but let's say the region right behind my head here, it's another deep field. Every single speck that doesn't have these diffraction spikes is a galaxy. Look at that guy. Or that little disk. This one's beautiful. What's going on up over there? Yeah, there's 5 bright galaxies here, but there are thousands more behind them. Are the new JWST images CGI? No! Stop that! Cut that out. But they are false color. In fact, pretty much every picture you will see from a telescope is false color. The detectors on telescopes can't take color images. The raw data is always black and white. Telescopes can't tell you what color the light is. All they can tell you is whether or not there is light coming from a specific region of the sky. So how do you turn this into this? The answer is filters. You can put a filter over the telescope that essentially says, for this next picture, I only want to let through the red light, the orange light, or the blue light, or the yellow. And then you can just overlay all of those images. Here's a great image with actual astronomical imagery. Here, remember, each one of these colors is actually just black and white data. Is there red light there or not? But when you overlay the red color and then stack them all up, you get a full color image. With JWST, it's a little bit more complicated because JWST is an infrared telescope. That means if our human eyes were to look at the data that JW collected, it would look dark. We can't see infrared light with our eyes. So in order to add color to the JWST images, not only do they have to split the image up and take it with a bunch of different filters, they then need to assign a visible light color to each filter. So essentially, you take the rainbow of visible light and overlay it on the infrared data that JWST receives. And with that, you can make full color images like this beauty. So it is false color, but it's still showing the universe as it is, and they keep the order of the colors, so you wouldn't have the shortest wavelength light being red. The shortest wavelength light is still blue, like it is in the visible spectrum. And adding this false color is really important for the science we do too, because otherwise we wouldn't be able to clearly detect all of the interesting structures and phenomena going on in these images. The addition and heightening of this false color allows us to see the structure that makes these images so revolutionary. And even though the JWST images are false color, and this isn't what it would look like to our eyes, don't worry, the universe is still astoundingly colorful and beautiful in the visible range of wavelengths.